On to the fourth set of questions in your end-of-year assessment. Solve those simultaneous equations. There are so many ways to do this. I'm going to look to do this just simply by elimination, but there are lots of other ways. I'm going to call my equations 1 and 2, and I'm going to look such that I can add or subtract my two equations to eliminate one of my variables. So in this case, I'm going to multiply equation 2 by 2 to give me 2x plus 4y is equal to 16. And I'll call that equation 3. So now if I add 1 and 3 together, I'm going to get 5x plus 2x, find a minus 4y plus 4y. So that just gives me 0y. So that's what I'll do. 3 plus 1 gives me 7x, 5x plus 2x, minus 4y plus 4y is 0, is equal to 19 plus 16, 35. And so x is equal to 35 divided by 7, 5. I've not finished there because I need to find my values of y for which that is true as well. So I substitute back in, and I'm going to substitute back into equation 2, because that's slightly simpler. So I've got 5 plus 2y equals 8, because x is equal to 5. So 2y is equal to 3, so y is equal to 1.5. And so I've solved my pair of simultaneous equations. They're both straight lines, so I would expect one pair of solutions. Question 11. Here is the graph of y equals 5 minus x for values of x from 0 to 5. On the same grid, draw the graph of y equals x plus 1. So that's in the form y equals mx plus c. So I know my y-intercept is 1, and my gradient is also 1, which means if I go up in x by 1, I go up by y in 1. So go up by x in 1, go up by y in 1, up by x in 1, y in 1, x in 1, y in 1. This could cause a few problems for you in that the axis intervals are not the same on x and y, but that's fine, and you just need to notice that. I then take my ruler, I join all of my points together, and really I should have marked the next 2 points as well, but I know what they are in my head, so I can just use that to check my line is nice and straight, and I've drawn it. And then I'm asked to use the graph to solve the simultaneous equations y is 5 minus x and y is x plus 1. In other words, what is the value set of x and y where both of those equations are the same? Just like I was doing up here algebraically. So that is where the coordinates of each line is the same. And there's only one point here where they cross over, and that's when x is equal to 2 and y is equal to 3. Now I could, if I wanted to, just check that that did solve each equation. So when x is 2, y is 5 minus 2, 3. When x is 2, y is 2 plus 1, 3. So that makes sense. That tells me what I'm doing is correct. Question 12. The sign says when a lift is safe to use, the total mass of people must be 480 kilograms or less. Fred and some other people are in the lift. Their total mass is 565 kilograms to the nearest 5 kilograms. So I'll call that M. So I know their mass is somewhere between 562.5 kilograms and 567.5 kilograms. Any lower or higher than that interval, and immediately I'm going to be rounding either to 570 or to 560. Fred, who has a mass of 88 kilograms to the nearest kilogram, gets out of the lift. So Fred's mass is between 87.5 kilograms and 88.5 kilograms. Once again, anything below 87.5, it would be 87, not 88. Anything above 88.5, be 89, not 88. Is the lift now safe to use? So I'm looking for my worst case scenario here. I need to know that it's definitely safe to use. So that is to assume that the total mass is heaviest, 567.5, and Fred's mass is lowest, because that's the worst case scenario, right? There's even more mass in the lift, and what I'm removing from the lift is lower, 87.5, which gives me 567.5 minus 87.5, 480 kilograms. It says the mass must be 480 kilograms or less, so in the worst case scenario it's 480 kilograms. Therefore, anything below 400, or any other scenario, it would be below 480 kilograms, and therefore, yes, it is safe to use because it cannot be over 480 kilograms. And that's another 3 questions sorted.